Today we're going to review exponent rules. So we have properties of powers. So we have the power of a power property. So x to the a to the power of b equals x to the power of ab. Numerically, that means like x squared to the power of 3. You'd multiply 2 times 3 and you'd get x to the 6th power. Product of powers, x to the a times x to the b, you add those, so x to the a plus b. So with numbers, x squared times x cubed would be x to the power of 2 plus 3, or x to the power of 5. Quotient, when you have powers on top and bottom, you subtract. So this would be x to the a minus b. And again, this only works with the same base. So those are both x, so we can do that. So if we had x cubed over x squared, that would be x to the 3 minus 2, or x to the first power, or you could just say x. Power of a product, xy to the power of b, you just distribute the power. So this is just x to the b, y to the b. So if you had x squared y cubed to the 4th, for example, you would have x squared to the 4th, so x to the 2 times 4, which would be x to the 8th, y cubed to the 4th, y to the 3 times 4, or y to the 12th. And it works similarly for quotients. This would be x to the b over y to the b. Okay, so if I had x squared over y cubed to the power of 4, I would distribute, and I'd have x to the 2 times 4, or x to the 8th, y to the 3 times 4, y to the 12th. As far as the zero exponent theorem, anything to the 0 power is 1. So x to the 0 was 1, 2 to the 0 was 1. Maybe you have like a squared, b to the 4th, c to the 5th, d to the 18th. If that's all to the 0, that's awesome, because the whole thing just turns to 1. And lastly, the negative exponent theorem. Basically, x to a negative power is 1 over x to that positive power. So x to the negative third is 1 over x to the positive third. 2 to the negative first power is 1 over 2 to the first power, which is 1 over 2. Maybe you have xy squared z to the 4th to the negative 5th power. Since that negative 5 is going to all of that, we'll put it all on the bottom of a fraction. So we have 1 over xy squared z to the 4th. All of that's to the positive 5th power. Now I'm just going to show you a bunch of examples. So it should be familiar. I know you've learned it in a couple of classes, but there's a lot going on with these, so it's easy to forget and need some extra practice. So for the first one, 3x to the negative second, there's honestly a couple options. There's the thing with exponents is there's almost always more than one way to do these, so I'm just going to show you the way that's instinctive to me. But if you can do it another way and get the right answer, feel free. So 3x to the negative second. What I'm going to do is take this negative power, so I'm going to make a fraction and make it 1 over 3x to the positive 2, which is 1 over 3 squared, which is 9, times x squared, which is just x squared, and we get 1 over 9x squared. For the next one, I'm going to keep my fraction because I'm going to need one. First, I'm going to take 5 over 25, and I'm going to simplify that. You divide top and bottom by 5, you get 1 over 5. And then I have a y to the negative 5th power, which I'll put on the bottom and make it a positive 5th power. X to the negative third, I can move it up and make that a positive third power. So I end up with x cubed over 5y to the 5th. The third one, 4x to the negative 7th times negative 2x to the 5th times y to the 0. I'm going to get rid of the 0 power because that's just 1. And then I'm going to multiply this together. So 4 times negative 2 is negative 8. X to the negative 7th times x to the 5th is x to the negative 7 plus 5. So we end up with negative 8x to the negative 2nd, because negative 7 plus 5 is negative 2. And in our answers, we'll typically be asked to only include positive exponents. So I have the negative 8 over x to the positive 2nd. The negative 8 stays on top because that negative 2nd power only applies to the x. Next one, we have options. I would like to take care of this negative exponent first because that's my instinct, but you could distribute it here as well if you'd prefer. So I'm going to make a fraction bar. The 4x will go on top. And then on the bottom, we'll have 2x in parentheses, and since we moved it, it's not a negative 3, it's 3. So 4x over 2 cubed is 8, x cubed is x cubed. Getting closer. We still have a fraction. 4 over 8 simplifies to 1/2. And technically this is like x to the first power. 1 minus 3 is negative 2. So we have 1/2 x to the negative 2nd power. And so then what we'll do to keep it positive exponents, 1 over, and we'll stick the x squared on the bottom and make the power positive. So 1 over 2x squared. For the next one, I'm going to start with my fraction. 10 over 8 simplifies to 5 over 4. And then I have x squared over x to the negative 3rd. 2 minus negative 3 is x to the 5th. Y to the negative 2nd over y to the negative 1st. Negative 2 minus a negative 1 is like a negative 2 plus 1, which is a negative 1. And so we're close, but I don't want any negative exponents. So I'm going to have 5x to the 5th over 4, and I'm going to take this and make it a positive 1 and just make it y on the bottom. Y to the first power, but we don't need it. 5x to the 5th over 4y. Just a few more. So really there's options. The first thing I'd like to do is get rid of this y to the 0 because I know it's 1. So we don't have to deal with it. I'm going to make my fraction bar. For the moment, so if I deal with the x to the 4th, that can stay because it's positive. Z to the negative 3rd, I'm going to put it up top, make it positive. Okay, so it's z cubed. Z to the negative 2nd on the top, I'll move to the bottom and make it positive. And 5x to the negative 2nd, it's not what I meant to do at all. I meant to circle it, or oval it, I guess. 5x to the negative 2nd, I'll put that on the bottom and make it 5x to the positive 2nd power. Now it looks a little better. So I'm going to keep my fraction. Let's see, the x to the 4th stays. Z cubed over z squared, 3 minus 2 is 1, so we end up with a z to the power of positive 1. 5 squared is 25. X squared is x squared. So close. Top we have z, because we don't need the 1. X to the 4th times x squared. 4 plus 2 is 6. So we have x to the 6th, and I'll put 25 in front. The last two are a little long, but you can do it. It's hard to be motivating when right now I'm actually doing this lesson for my cats and they're sleeping through it. So hopefully you guys aren't sleeping through it as well. Maybe I'm just putting them at ease. That's good, right? Okay. So let's see. There's really, again, there's options. I'm going to keep the 2 over 3. Doesn't simplify. X to the 4th over x squared. 4 minus 2 is 2, so I end up with an x to the positive 2nd power. Negative 4 minus negative 3 is a negative 1, so I have y to the negative 1st power. Negative 3 minus 4 is negative 7, so I have z to the negative 7th power. The last thing to do is move the negatives, okay? So I'm going to have 2 and 3, x squared. I'm going to take the y to the negative 1st and put it on the bottom and make it y to the 1st. Z to the negative 7th, put it on the bottom and make it z to the 7th. You can leave it there, but no, you'll never see a 1 as an exponent because mathematicians are kind of lazy that way. If we don't have to write it, we don't. So we'll end up with 2x squared over 3y z to the 7th. Oh, I was boxing. Back to bubbles. or clouds. I tend to like the clouds. All right, next one, last one. So first q to the 0 is 1, so it's gone. This is looking kind of icky, so let's just start somewhere. I would like to put this whole thing on the bottom and make that -4th exponent positive. So I'm going to put a 2p m to the -1st, that q to the 0 is gone, to the power of 4, because now I've moved it. Okay? The 2 will stay. The p cubed will also stay. The m to the -1st, I'll move to the bottom and make it m to the 1st. And then I'll keep the 2pq squared on the bottom. And if you're thinking like, I wouldn't have done that, I would have done something different, is that bad? Again, it's not bad at all. I might do it differently if I did it a second time, honestly. So it's no big deal. So then 2p cubed is on the top. I'm going to distribute this 4th power. So I have 2 to the 4th, which is 16, p to the 4th, m to the -1 times 4, which is m to the -4th. And now I have my m to the 1st and our 2 and p and q squared. Okay, again, the order doesn't matter. Let's see, I'm going to leave 2p cubed on the top. And then I have 16 times 2, which is 32. P to the 4th times p, that's like a first power. 4 plus 1 is 5. So I have p to the 5th. M to the -4th times m to the 1st, -4 plus 1, m to the -3rd. Then I have q squared. Getting close, I promise. Okay, so 2 over 32, 1 over 16. Let's see, I'm going to, with the p's, p cubed over p to the 5th, 3 minus 5 is -2, so I have p to the -2nd. I'm going to move the m to the -3rd up and make it +3, and the q squared stays on the bottom. We're so close. Okay, now on the top, I have an m cubed. I also have a 1, but we don't really need it. On the bottom, we have 16. I'm going to move this down and make it p to the 2nd power and q squared. And we're done.